Okay, so what we're going to do in chapter 10 is I'm going to go over the concepts first. Yeah, then we'll go through an example in Excel to understand the concepts, how to develop the model, and then we will look at R, okay, how to do logistic regression in with the real data. Okay, so that's what we're going to do. Logistic regression, the basic idea is, okay, as opposed to regular regression. In regular linear regression, your y, the target, is an interval variable. It can take any value, right? But in a classification case, the target can take only, in the case of binary target, it can take only two values, 0 or 1. If it is nominal or ordinal, there may be just a few handful of numbers, unspecific numbers. Okay? It's not a real number. It is an integer, just a few. Okay? So that's what your y hat should come up with. So if you use a regular regression model, okay, with Q predictors, okay, so if you use a regression model like this and run a regression, and you come up with an estimate like this, okay, you have your intercept estimate and then the slope estimates. Then you plug in all these values, the x values into this equation, and y is not going to be 0 or 1. It can be anything. As a matter of fact, it need not be between 0 to 1 either. It can be a negative number, or it can be a really large positive number. So there is no guarantee that this is going to give us either a 0 or a 1. Okay. It's almost certain that it's not going to give you 0 or 1. So the regular, the classical linear regression model is not going to work. Okay. So we have to come up with some other idea. Okay. So one way of dealing with this is, okay, this is a classical way of converting. So if you have possible values, when you run the regression, your y happens to be anything, right? It can, theoretically speaking, it can go from negative infinity all the way to positive infinity. So it can be any value. Now if you want to compress that into a 0 to 1 range, okay, this is what you need to do. If you take that predicted value, so if you make a ratio like this, 1 over 1 plus e is a constant like pi, right? So e to the power of minus of that. If you do that, then you're guaranteed to have a value between 0 and 1. Okay, so it will be something like this. Okay. So here is our, we'll call this L. Instead of y hat, since it's not y hat, we'll call this L. Okay. So L, logit function, some people call it logit function, logistic function. So that is your regression equation. And this is going to give a value anywhere between negative infinity to positive infinity. But if you take that L and put it into this function, if you do 1 over 1 plus e to the power of minus L, okay, this is what you'll get. So your p is going to go from 0 to 1. Okay, so all the way to the negative side. Okay. As L goes towards negative infinity, this value 1 over 1 plus e to the minus L will go closer and closer to 0. Never crosses 0 to the negative side. And similarly, as L goes to the positive side, as it gets closer and closer to the largest possible value, infinity, it will slowly go closer and closer to 1, never crossing 1. Okay? So that's good. Now we have taken, we have done some modifications that will ensure that the predicted value is going to be between 0 and 1, and that's a big improvement. But we're still not there because we want either 0 or 1, right? Now, this value being between 0 and 1 then gives us an opportunity to treat that as probability. And so you can have a cutoff point, and you say, okay, cutoff is 0.5, so anything less than or equal to less than 0.5 is 0, greater than or equal to 0.5 is 1. So that's one way of dealing with coming up with a classification of 0 or 1. So that's what logistic regression approach is. The basic idea is to come up with a logistic function, okay, which is L is dot, okay, and then do this, and that will give you a value between 0 and 1. But now the problem is, how do you estimate from the data? So you have the data, you have the target, you have all the predictors. Now how do you come up with these b sub 0, b sub 1, b sub 2 values? How do you do that? Okay. Now, since we are converting, so we need to make sure that the number 0 to 1 for p is consistent with whenever y is closer to 0, the actual y is closer to 0, the p that we get, I'm sorry, when the actual y is 0, we want this p to be close to 0, right? Otherwise your prediction will not hold true. So if you have all your x's, right, so your target is here, target is 0, so your L should be such that you convert it into p, okay, that p is very small because your target is 0. Okay. So the actual probability of target is 1 minus p. Okay. If the actual target is 1, your L should be such that the p that you get will be large. Okay. So when p is small, the probability that the actual value of y is 0, okay, is very high. Okay. When L is large, then the p that we compute would correctly predict the target value is 1. Okay, so that's what we need to. So in a perfect model, whenever you have a 0, your p should be equal to 0. Whenever target is 1, your p that you calculate should be equal to 1. So your perfect model prediction probability of the actual target value is always 1. Okay, if it is 0, p will be 0, so you get 1 minus p is 1. If y is target is 1, then p will be 1, so that would be the probability. Okay. So what we need to do is to come up with our estimates in such a way that the p's are very small when the actual target is 0, and the p is very large when the actual target is 1. Okay. And to do that, we come up with this equation. So that is, if target is 1, value of the column must be p, and if target is 0, the value of this column must be 1 minus p, okay, the probability of the target. So how do you set that up? Okay, here is the answer. So you take the p sub y, okay, to the power of y times 1 minus p sub y to the power of 1 minus y. If you did that, when y is 1, this formula will calculate out to be p. When y is 0, this formula will calculate. You plug in 0 and you will get 1 minus p. Okay. So that's what we have to do. And okay, so now we can compute all of these probabilities using this function. And we want those probabilities to be, we want the slope and intercept to be such that this product, okay, you multiply all of these probabilities, that's that gives you what is called likelihood function. And that likelihood function, you want to maximize the likelihood function. So you multiply all of these. So when you have a multiplied objective to be maximized, it's very difficult. So what we can do is so this pi here is the equivalent of sigma. Okay, when you're summing, you put sigma, right? Sigma stands for sum of. Okay, pi stands for product of. So here, this is the product of all of these values. And if you take a logarithm of both sides, so you end up with sum of this. Okay. And our maximum likelihood function is this logarithm. And then now we have a summed function that we want to maximize. So that's the problem that we have. Okay. All right, now let's, so this is, right now it's all theoretical. So let's now put this into an example and then see what all of this means. Okay. So we will do this in Excel.